All right, problem 2, we have that f and g are the functions defined where f of x is equal to the natural log of x plus 3, and g of x is equal to x to the fourth plus 2x cubed. Graphs of f and g are shown in this figure above, and they intersect at -2 and at x equals b, so over here. Part A, find the area of the region enclosed by the graphs of f and g. Okay, so you should know that this top graph will be f of x, that's the natural log of x plus 3, and then that means this other graph will be g of x. Let's label that first. So to find the area of this region, you want to basically take the integral of g of x minus f of x from -2 to whatever this point is here. So let's graph these and let's see where they intersect. Since this is a calculator problem, this makes it very easy. Let's delete everything, yes. Graph function. Natural log of x plus 3. Graph function x to the fourth plus 2x cubed. Let's zoom standard. Whoa. Calculator's going crazy here. Okay, so now let's analyze this and see where they intersect. Okay, so it looks like that point is at 0.782, and y value is 1.33. So let's label that over here. 0.782, 1.33. Okay, so the area will then be equal to the integral from -2 to 0.782 of g of x minus f of x, top minus the bottom, dx. And again, let's just use our calculator to take care of this work. Calculus integral, numerical integral from -2 to 0.782. We'll have the natural log of x plus 3 minus x to the fourth plus 2x to the third. Dx, make sure I don't make any mistakes with some point. Let's see what we get. 3.6. Okay. Yeah, that makes sense to me. About 3.6035. All right, part B. For x between -2 and b, let h of x be the vertical distance between the graphs of f and g. Is h increasing or decreasing at x equals -0.5? Give a reason for your answer. Okay, so if h is the vertical distance between these two graphs, that's, we can think of it as like, this line segment. That means that h of x is equal to f of x minus g of x. So let me actually write it over here. So I'm not cramming. So h of x equals f of x minus g of x. Now, if we want to, see if h of x is increasing or decreasing, then we're going to take the derivative of h of x, which is going to be equal to the derivative of f of x minus the derivative of g of x. And since we want to find it at this specific point, we're essentially just going to take h prime of negative 0.5, which is going to be equal to f prime of negative 0.5 minus g prime of negative 0.5. Now, if this ends up being a negative number, that means that the distance is decreasing. If this ends up being a positive number, that means the distance is, or the h of x, which is the distance between those two functions, is increasing. So negative decreasing, positive increasing. So let's again use our calculator to just take care of this work. So let's go to numerical derivative at a point. Our point is going to be negative 0.5. Let's just make sure we enter our expression correctly. So natural log of x plus 3 minus x to the 4th plus 2x cubed. Let's see, we get negative 0.6. Okay, so then that means that decreasing since h prime of negative 0.5 is negative. Since h prime of negative 0.5 is less than 0. Part C. The region enclosed by the graphs of f and g is the base of a solid. Cross sections of the solid are taken perpendicular to the x-axis or squares. Find the volume of the solid. Okay, so it might be hard to draw this, but essentially you're going to create squares with this side length. You know, this will be like, there'll be a square with this length. Over here, the square would be this length, would be much wider. Over here would be something between. So you're basically going to take the integral from negative 2 to 0.78x, and since this is the side of a square, let me just draw a picture like over here. Think of this as like h of x. And since it's a square, that means that this side, sides are all congruent. That means this side is also h of x. And you know, how do you find the area of a square? You take the side length and you square it. So you basically are taking h of x squared, and since h of x is equal to f of x minus g of x, you're going to take f of x minus g of x squared. That'll be your expression in integral, and then you're going to basically integrate that from negative 2 to 0.782. So the volume will be equal to integral from negative 2 to 0.782 of f of x minus g of x. That whole expression needs to be squared, like that. So again, let's use our calculator to take care of this. Numerical integral, negative 2, 0.782. Natural log of x plus 3 minus x to the 4th plus 2x to the 3rd. Whoa, it's not. Now this entire expression needs to be squared. There we go. So remember, this expression here is h of x. We integrate that, and that should give us our volume. Wow, no, I entered the brackets. That's annoying. Okay, let me do the thing again. Let me try to do this quickly. 0.782. That's not correct. Minus x to the fourth plus 2x to the third all squared. That should work now. We get 5.34. All right, part D. A vertical line in the xy plane travels from left to right along the base of the solid described in part C. The vertical line is moving at a constant rate of 7 units per second. Find the rate of change of the area of the cross section above the vertical line with respect to the time when the vertical line is at position x equals negative 0.5. So this can be confusing if you overthink it, but you're essentially you're gonna just apply this chain rule to this integral. So you're looking for the rate of change of the area of the cross section. The area of the cross section, let's call it A of, A of t or A of x, since we're talking about time, is basically, the side length squared, which we found to be, f of x minus g of x squared. That's the area of each cross section, because that's the side of, we're talking about, the squares. Now, if when you look at this, you can tell that the cross section lengths are changing size. It's a little bigger here and it's decreasing and it's getting smaller here, until it eventually gets to the dot. So you're essentially just going to find a prime of t for when x is negative 0.5. So this is basically just, taking the derivative of this, but you're basically doing chain rule because since you're going to be multiplying the inside by dx dt for each of these. So if I kind of give you I'm not going to go through it all by hand because it's more tedious. We'll use a calculator, but essentially it looks like this: f of x minus g of x. We take the power rule, then multiply it by the derivative of the inside. The derivative of the inside is f prime of x, then you do dx dt minus g prime of x times dx dt. And that dx dt is that 7. That's describing how, it's changing over time. So what we can do in our calculator is we just take the derivative of this and then multiply our equation by 7, because that's what dx dt we're multiplying. You can essentially factor out the dx dt on the outside, and that will just make it like a 7. So it's kind of like if I was to cross that out and put like a 7 there, dx dt is 7. So anyways, so again, we'll leave it to our calculator, where we're going to take the derivative of the area at, what was it again, negative 0.5? Negative 0.5, which is equal to f of x minus g of x. Should have this memorized by now. Natural log of x plus 3 minus x to the fourth plus 2x cubed the entire expression is squared, remember? Oh crap, no. I gotta make sure I put this in the parentheses. Okay, and then I put that, because that's okay, yeah, that's the area. then I multiply this by 7. And that's our answer, about negative 9.27. The units per second. And that's all there is to it.